sorry I'm late, but I made it. And I always just want to say, if you're a regular, you hear me say this every time I speak, but the people that come out here, wow, thank you for sacrificing your personal time to listen to us go on about SLOs, which is great. So thank you, and to the remote people as well. I switch tabs, you don't see it, right?
Nope.
Perfect. Okay, so just a little bit about me. Most of you already know, but was the co-founder of this place. Passionate about DevOps. I dreamed of automated SLOs at one point, and the developer experience and Carson made it happen, and then made it 10 times better with their dreams added to it. So I'm super stoked to see his part of the presentation because he's going to go in depth on the technology, and it's super fun. And now starting a new startup with Jason, who's here. We're excited about it. So because of Weave's success, I get calls a lot from startup companies or venture capitalists, or hey, will you talk to our CTO or talk to our engineers and give them some advice? And it's not because I'm brilliant, it's because people correlate success with competence, and they're wrong, but I love it for my ego, so I just say, yeah, I'll talk to them. And inevitably, this is a question that gets asked all the time. What percentage of time should we be spending on technical debt?
97%.
90s? Oh, man, I have a video too. Is this not going to work?
Which tabs?
Maybe. Oh, it's in the presentation.
Should I use let or const for my variables?
Okay, so the answer, if you've been an engineer for a long time, this is the answer to pretty much every question that ever gets asked. This is a video from GitHub Universe. She went back in time to talk to herself and give herself advice.
It depends. Object-oriented or functional programming? That depends too. Okay. Strict, loose, or static typed languages? It depends. Dark mode or light mode? It depends. Windows, Mac, or Linux? That depends too. Joey or Chandler? Are you really asking me this question? It depends. Netscape or Internet Explorer? I bet it's Netscape. YAML, XML, or JSON? I gotta say, it depends. Okay, should I merge, squash, or rebase? It depends. Should I use semicolons? Depends on so many things. What branching model should I use? It depends. Okay, how much unit testing is enough? It depends. Vim or Emacs? That depends.
No, it doesn't.
On if you suck.
It is.
Oh no. Oh no.
Depends on if you suck, because you should be using Vim. So when someone asks me that, the answer is usually it depends. But I think what you want to do is empower a team to be able to make that decision for themselves by giving them some sort of framework. And so this is usually now the way I answer that question. For any given service, this is from a technical side, right? For any given service, are its users happy enough with its reliability, functionality, and security for the business to keep growing and succeeding? That's how I answer that question, should you be working on technical debt versus new features? Okay, so if the service is working well, customers are happy, like, just leave it alone. Like, don't work on it. I mean, unless Jason, I'll give you a caveat today. I had the security in there. He's like, unless there's some glaring security flaw that hasn't been addressed. I think this is a good start. I'm not saying it's a silver bullet to the question, but I think it's a good start to answering if you should be working on technical debt or not. So, how do you measure user happiness at the service level, like from a technical side? And that's what we're talking about today. It was very well illustrated in Google's books that they created, or Google employees anyway, on site reliability engineering. And they have the workbook and the handbook, and the SLO chapters in there are essential reading, I think, for any engineer to understand how SLO works. I think that all engineers should understand it. It's important. So, me give you quick definitions. I'm not going to go in depth on these because you should just read the chapters. I'm not going to stand up here and go over the chapters for you. But a service level indicator is essentially a metric. It's a metric that measures the aspect of a level of the service, okay? It's not every metric is a service level indicator. It's the ones that are going to measure customer happiness, user happiness for that service. Examples are latency, error rate, or data freshness. SLO, the objective, this is the target value. So this is where you want to be. Some examples of that are like P99 latency, less than 100 milliseconds. That would be 99% of requests are less than 100 milliseconds. Or from availability standpoint, like 3 nines, 99.9% of requests don't error, no 500 errors for availability, okay? That's some examples there. And then the last one, and this is really the thing that allows you to make decisions on whether it's tech debt or reliability, you need to focus on that type of work, is your error budget. And this is the amount of errors that are allowed within your SLO. And so if you had an SLO of P99 latency of less than 100 milliseconds, like the example was there, over rolling 7 days, if you got 1,000 requests over those 7 days, you can have 10 that are slower than 100 milliseconds. That's your error budget, is 10. That's it. If you go more than 10, you're over your error budget. You've exhausted it, okay? So hopefully that simplification of these definitions helps you as you go through the technical deep dive with Carson. I'm just gonna walk through a quick example and then I'll turn over the time to Carson so you can just get a visualization of this, okay? So Acme Software Company, I did 2 slides of the same. We'll go to this one. Acme Software Company, they make a to-do app where you can store your to-dos. And product and engineering got together and defined service level indicators that they think measured customer happiness for their app. The ones they came up with are very basic, very common for this type of user app, latency and error rate. Right? No one will use an app that's too slow, first of all. They'll get to a point where they're frustrated or call support. And no one will use an app that errors out all the time. They'll allow a certain amount of errors before they get frustrated. If it happens not frequently, it's okay, right? But if it happens too frequently, they become unhappy. And so this is the proxy metrics for measuring customer happiness on the technical side, on the performance side. And the SLOs they defined are P0, so 90% of requests have to come in at 100 milliseconds. But just to make sure that the other 10% aren't like 8 seconds, they add a second SLO for latency saying 99% have to be less than 300 milliseconds, okay? And then they did a 3 nines of availability. And then their developer experience team, really awesome, helped put some graphs together and alerting for them. This is very contrived. You would have much more detailed graphs, which you'll see from Carson. But that's showing your error budgets. And it should alert you if anything is amiss, okay? And as you can see here, these SLOs are well above their error, but they have plenty of error budget at 100%, right? Floating around 100%. The availability is floating around 60%. Still tons of error budget, and it's staying about those levels. But then Acme gets 1 million signups in a week, and it starts, you start seeing some degrading, right? I know these had animations, that's pretty. Then you start seeing, and I mean, it just depends, but I always think that the fastest requirement is the one you're gonna see degrade first in these type of apps. They see that P90 of 100 milliseconds is starting to degrade, and the slope of the error budget is now declining so that maybe in 2 weeks or 8 more weeks, whatever the measurement is down there, you're gonna hit 0 and go below it. But it gives you a nice heads up, like, hey, we're not gonna hit our error budget if we keep maintaining these error rates. And so in their next sprint planning, instead of working on new features, they come together and they say, hey, we should work on some performance technical debt. Let's go make sure our database has indexes. Or we're not doing 25 left joins. I don't know it's always the database fault, right? But they can go diagnose it and spend that sprint solving that problem. And product has already agreed to these SLOs and said, yeah, let's do it. Let's stop feature requests. Go to the organization and say, yep, we got to stop because we will lose customers if we stay on this path. And it's very clear data to show you that customers will not be happy if we stay on this path. That's, yeah.
How do you articulate well to the business PMs that don't have this kind of terminology in their background? I mean, you talked about it a little bit, but how do you actually make that case to say, hey, we need to not do that feature, we need to do the technical bit?
Yeah. So I think the first thing that you'd have to do, and you read the chapters, it talks about it in a little bit more in depth, is you need an error budget agreement beforehand, or at least come up with one if it doesn't exist, right? And you say, okay, we've defined our measurement of customer happiness for the service. Here is the rule set that we're gonna put together, and I need you to agree to this. Product owners, executives, whatever. This is the framework we're gonna operate. And the vocabulary you use here is just, if it gets too slow, right? Or it starts getting, like you can say availability is buggy, right? It's too buggy. Like you don't want to have to say, hey, we have a race condition that only fires one error every 10 times or whatever. They don't care about the details. It's just like customers are seeing bugs, and it's gotten to the point where the happiness is degrading and support calls are going to go up. And I think what happens is they get really impressed that you can show, it's not really predictive because these are problems happening, but it is a little bit predictive in that it's not like completely like an outage yet. You can just say like, oh yes, something's off here and we're gonna fix it before we get to this, exhaust our error budget. And I think that really helps. And if you present it the right way, they'll be impressed. Like, yeah, okay. I even had a venture capitalist even say that to me. How come we have portfolio companies that can predict their outages. How come you guys aren't predicting your outages? I was like, is this happening right now? So some guy had like suckered these guys into thinking that they're predicting their outages. I'm sure it was something like this, right? Where it's like, oh yeah, we see if we don't take care of this, we're gonna have an outage. Yeah, we predicted it. No, it doesn't have to be like that. Anyway, that's the super contrived, simple example. I'm gonna now turn the time over to Carson and.
I can ask a question real quick.
Yeah.
We gotta switch anyway, so.
We might get into this with Carson stuff, but I can see how that works for, it's slowly degrading or whatever.
Yeah.
How do you deal with, right? It's always the database, right? Your database goes down, or like
An outage.
your platform, right? GCP goes down.
Yeah, like if an outage happens.
Like that, right? If all of your services are relying on
Yeah.
that thing, and now all of a sudden you've blown all your error budgets everywhere.
On dependencies. That's
Yeah.
that's so great. One of the SLOs they actually remember. So for the service dependencies, one of the ones that they talk about is how it degrades. They call it quality measurement. Does it degrade well when its dependencies are gone? So that's something that you could look at. If they say look at them on different time horizons, and that's what I'd recommend for that. The default they recommend is a rolling 28 days in the manual because that gives you 4 weeks of good data. And you can look at it and that gives you enough time to say one outage is not gonna cause, unless it was like really bad, it's not gonna exhaust the error budget, right? For most instances. But if it does, it might be a case to look at it with the product owners and with the engineering team and say, if this outage happens again, like are we gonna lose customers? Is this gonna affect the business? And make a decision based on that data, using that data as one of your inputs for the future.
And some of that like towards a platform team, right? You're providing a database, you're providing a cache, or right, you don't want every team to like reinvent and paper over all of their, upstream dependencies.
Like,
Like, at least that's my perspective.
What do you mean?
Like if every service is assuming that the one that it's relying on is gonna go down, and then you have every team and every app, building in failover, like, it seems like it's a lot of wasted work that should be absorbed by the platform.
Yeah.
I have a different opinion on some of that. I feel like it doesn't matter. Your error budget is your error budget, your latency objectives are your latency objectives. Because your users don't care that you had an increased error rate because of the database. Like, I explained it on a call the other day when I was doing Clint's job because it was with just an internal call. I explained error budgets as a measure of user patience. And that the user patience, as you burn that, that's, people are forgiving, people can hit refresh, they can deal with a little slowness a little bit at a time. And then if they go long enough, they build that tolerance back up. And so at a certain point, I don't care. The user is not gonna get, oh, it was the database. That's okay that you're slow again. Like, you have to, the budgets are the budgets, and they're about business decisions. And you can choose to ignore them. Like I said, they're data points you get to handle. You can even have a really low budget, and the way I'm gonna show you how to do alerts, a really low budget, you could be in the negatives and still get another alert for another big drop later. You don't have to be back up above even a positive number to continue to use error budgets and alerting to as that measure, right? So,
And I guess I would hope
that's my
that
opinion.
your dependency tree hopefully wouldn't be too long. I think in Weave, we let it get out of control in some instances where it's like, oh, you don't want to go 5 services deep because every SLO is going to depend on that one at the end or whatever. But also as they go deeper, sometimes those SLOs are going to be harder. Like the auth service at Weave has to be a more aggressive SLO than the forms service, right?
That's kind of my point, right? You've got auth, you've got the database, right? There's a couple that,
But you've also got, SLOs on all those individually, and you can use that as a measurement to narrow down where your problems are, right?
so, and every team is then just baking in the auth and the database SLOs and lowering it by a set amount.
Yeah, I mean, let's
no.
do this stuff, and I think after, we'll have a party that.
That's just one of my biggest questions.
They build their SLOs based on what their users need. It doesn't matter what their dependencies are. And then if the dependencies don't match that need, there has to be a problem. The problem has to be addressed at the business level. Like it's not.
Well, that's my point, right? For the business, I don't want every team to rebuild its own database or its own cache that they're probably not equipped to
You have to
do.
go back to the platform team and say, this SLO isn't good enough.
Right.
You have to make it better.
So how do you, I'm not certain that you do, but how do you work in the outliers? Mother's Day, Black Friday. How does that work? You talk about a 28-day window. But
Seasonality?
yeah, how do you deal with the seasonality aspects or just the anomaly aspects of
Yeah, we talk about it like in these ideals and these like simple
Yeah.
contrived instances, but it doesn't work in seasonality out of the box, right? And even, who's that famous, she was Google SRE, I can't remember where she works now. She does the open metrics and she tweets a lot about.
Joanna?
Yeah, she just said, someone tweeted, what company has like an ultimate ideal but never lives up to it? And her response was Google and SLOs. Right? Because it's complex, right? It's like every service is different. It's never gonna be perfect. But that would be something you'd have to figure out. Like if you have a Black Friday situation where all the traffic goes nuts, you're gonna have to come up with a specialized subset of SLOs for that time period, most likely.
And is that something that, I mean, for a SaaS company, that's kind of a common thing that's going to happen, right? You're going to have those things. You actually have an ability to inject the different error things for the seasonality and then pull it out, or what do you do?
All these budgets are based off your actual request volume.
Yeah.
So the more requests you get, the more
Gotcha.
budget you get.
Yeah.
So the whole idea is you don't want to cause your customers pain.
Right.
And so like Black Friday comes, like you don't want to cause pain on Black Fridays.
Yeah, it's all ratios.
Because
Let's get started. Well, like I said, we're digging, we have people online, so, that's the after, we'll go into all this, and it'll have more context with the numbers, I think. So, I'm gonna do the in practice and at scale. It's gonna start out really heavy with some math, then some Prometheus queries, and then some cool like Kubernetes and cloud native stuff at the end, and show you how we basically do SLOs for free at Weave at our scale. So I'm Carson Anderson. I am a DevX engineer at Weave. Recently, I think I got to be coined the official DevXO, which I love. I'm just taking that.
What is it?
I was talking about John's our team lead, my manager, and so we call him. I was like, okay, I was reading a sci-fi book, and he's the captain, and I'm basically the XO.
Oh, got it.
And so he's like, well, no, you're the DevXO. So I make it so. And like Clint said, one of our big jobs was Clint had this idea for SLOs. He had a lot of big ideas and plans and sort of left it up to me to make it possible. And I'll show you the stuff that, I don't want to drag you through too much, but I'll show you like where we started and how we made that possible.
It's fine. I crashed the Prometheus server several times.
Yeah.
So we some of the prototypes.
Yeah. I'm gonna have a Carsonoid. This is actually, rare thing for me. This is all on like Google Slides, but I'll export those and post them to GitHub because that's where all my talks always go. And my Carson_ops where I get sassy about tech things. So let's start in. What I want to do is give everybody a taste of like what you can do with a little automation, or a whole team working on this. But even if you can't get something this fancy, I want to sell a few concepts about like how you do SLOs for real and get people to buy in. Once you get the business to buy in, how you make it possible for your devs without blowing their brains, like with too much complexity. So what we do is there are two ways. There's really one way you set an SLO at Weave with the UI in front of it. And all you have to do is this left part. All you have to do as a developer is go into our code, and you could imagine this is an input to a Helm file, right? Everything I'm going to show you could be easily done with the Prometheus operator and Helm templates. Like that really would be enough to do most of this, or just, a Python script. It's not really that much at the end. But you set that, and we defined a bunch of predefined classes, and those classes are straight out of the Google SRE book. So there's critical, there's high fast, high slow, and low, and they all have some presets for these sentence structure objectives you're seeing here. And we thought it was really, really valuable to tell developers and anybody looking at this exactly what those classes mean all the time. So we always, whenever we can, put these objectives in the sentences like Clint was saying earlier. Because P95, P99, even I always have to think like, what does that actually mean? Whereas this is P99.9 or whatever it is. Or
It's like a sentence.
yeah, this is a sentence. Everyone says, well, this is my objective statement. This is easy to understand what I'm going for. We built off of the idea of a couple different latency tiers. You don't have to define all of these, but you can. So you either come to the UI and you hit save and it writes that file, you just go to that file and put that one line of config in. And that's all it really takes. If you want to customize it, you can do that. You can fill in all or any piece of this and save it, and it's going to put that big mess on the right. It's a lot of lines in classic Kubernetes YAML document style. It's a very long, liney config, but if you look at it, it's 5 things for every protocol. It's actually not that much config if you didn't want to get this strict about your data structure like we do. That's it. And we decided we're going to start with request-only SLOs and gRPC and HTTP because we had standardized metrics. And I'll get into those. But you hit save and you deploy. At the other end of our pipeline, and I'm going to go through the details of this, I just want to show you where you end up. At the other end of our pipeline, developers get something like this, which are real-life examples, sanitized to hide Weave and not drag any servers through the mud here. Real-life examples of the end-generated dashboard. So we take those exact statements that we showed you earlier, put them in the dashboard, show you where you're at right now and where you're at over time. And I'm actually going to get rid of this with something I'll show you later, but this is the 5-minute burn. So you can kind of see spikes and burns and try to correlate that to alerts you might be getting. Or look at this and say, okay, we want to do something risky with this service and its gRPC. We got a lot of budget to burn. Yeah, let's add features. Or we also do HTTP, and you see with this service, and you're looking at, well, it also does some different HTTP things, maybe some long file fetches or something that's not accounted for. We're not in a place necessarily to do new features, and we need to go address some of these underlying issues or give them time to resolve before we do new features for that service. You also get automated alerts. And again, I'm going to show you how to do all of this later on, but this is something that developers, once they put that one setting in, hit save and deploy, they get this at the other end. So I'm going to show you how we get there by first talking about how we calculate budgets in general math. Then I'll go into the Prometheus part of it. Then I'm going to talk about, like I said, once we go through a lot of math and Prometheus, I'm going to talk about scale and cost and cloud native fun stuff. So first I want to talk about getting this number. Clint already showed you why it's useful. I've already shown you, the chart over time, but how in the heck do we get this number? So I'm not going to read this verbatim. There are a few things you have to do. First thing you have to do is decide your window, right? The SRE book says 30 days. At Weave, we did 28 days.
It says 30 in the first one, then in the second one it says 28.
Oh, perfect.
That's what I did, 28.
There's a bunch of points where 30 days actually is what other calculations are built on a 30-day
They
metric.
don't like 5 weekends, that's why they did it.
Oh.
Sometimes 5 weekends.
Okay. Either way, you pick the window, and you'll need that later. Then we're going to need to calculate how many of fails we're going to allow. So for availability, it's how many requests we're going to allow to have maybe a 500 in HTTP, and then calculate how many have actually failed. Feed both of that into our equation, and we'll get our SLO budget on the other side. And I'll show you the details, but you got to pick this. This is important. I'll come back later. So, first thing to calculating SLO is figure out of the total number of things that have happened that count towards your SLO, for us it's requests, how many are we gonna allow to fail? And if this number right here seems magic to you, it's not. It is 90, in this case it's a 90% availability SLO. So it's that divided by 100 minus 1, right? So essentially we're saying 10% are allowed to fail. That's the other way of saying 90% have to succeed. So that's all that this number comes from, and it's those exact numbers from that dashboard or that file that I showed you earlier. So we say, maybe I had 50 requests come in, 90% SLO means I'm okay if 5 of those fail. Like, that doesn't mean you can't, that's not a problem, it just means according to the SLO, we're gonna accept that 100% uptime is not achievable in most systems, and not even beneficial to try to reach for because it has diminishing returns at a certain point. So we're saying, okay, 90% is a really, really permissive SLO. I don't think you'd see that in the real world. Like 99 is about the minimum we'd use, but it makes the numbers small and easy for this calculation.
Well, but in fail in this scenario would be
A 500
lower than 100 milliseconds. Like, it's not necessarily a fail.
It could be more. If it's an availability SLO, if it's an error rate, then it might be a 500 like server-side error. But you're right, for latency, it might just be a little too slow.
Like the 90, as a 90, like I could see, I mean, you had that in your examples for the
Yeah, you're right.
fast tier 1.
You're right. And so it really depends on what your objective is, right? You're right. If for latency, it might be okay, 90% might be fine. For error rates, that'd be really ridiculous. Like 1 out of every 10 to have an error is a bad system. But yeah, you're right. So we take that budgeted equation that we calculated earlier, we take what has happened in the window, 28 days, and then what we budgeted for, what's actually happened, subtract that, divide it by budgeted, and we get a budget at the other end. So as an example, 5 we've budgeted for, we've had 0 fail in the 28 days, we've got 100% of that error budget. So that's all that is. It seems so complicated, but it's just how many do you allow to fail, how many have actually failed, and run that through the equation. So you'll need these 2 things, and again, I'll show you the Prometheus stuff later, let's just get the math down. So we start here. Let's say later we have 1 bad request come in. So we've got 51 times 0.1, still rounds down to 5. We are not adding to what we budgeted for, but now we've dropped to 80% of our budget remaining, right? 5 minus 1 is 4 divided by 5.8. So it doesn't take much. Out of 50 requests, as soon as 1 fails, your budget's dropped by 20% in even this kind of really small case. Say we have 3 more bad requests come in. It's gone to 54 total, still 5, still rounds down to 5 that we budgeted for, but we drop all the way down to 20%. So how do we get the budget back up? And this is important to understand when you're looking at these budget charts later and you're like, oh, we're burning budget. We kind of understand how it happened. Bad requests came in, but how do I get this number up again? And there's 2 ways. One is good requests, and I don't mean just a good request. So 1 good request
Does nothing.
does nothing, right? We have to get enough that this equation spits out a bigger number on the other side. In this case, with this permissive amount and these small numbers, we need 5 more good requests to come in, and then we get a little bit of budget back. It's not just growing up nearly as fast as it went down, but you can process a lot more good requests, and the higher your budget is, if you had, 5 nines, you need a lot more good requests to grow even less. That's just how the math works. But the other way we can recover is time. So I've got a smaller window here where we have 25 requests, and you can see the ones that have failed. So right now, we have got 2 that we've budgeted for failure, which means our current error budget is actually negative 100. Your error budgets can go well into the negatives. They'll never go over 100 if you're not doing bad queries, but they can go well into negative. So we have got negative 2 divided by 2. We're 100% under budget. So how do we get this to recover? We either have a lot of good requests come in, or we have the time window slide off without any new good requests. As long as 28 days slides forward, or whatever your window is, as soon as those bad ones go off, we go from 4 bad to just 2 in the window, and we've gone up to 0%. So when you take both of those into consideration and you're looking at these budgets over time, sometimes they can pop up real quick, and that's because you've just slid off a big series of bad events off the end, and so it will grow quickly. So it can grow quickly given time, and it can grow slowly just by doing a lot of requests. And if you combine those, you can get actually pretty erratic budgets over time. So budgets can burn fast. That's really a big takeaway. It does not take much, especially at the high percentages, for them to burn down quickly. And you have to either have a lot of good requests or time to get back your budget. So that's the basic math. Let's do the Prometheus part first, and then I'll show you the way to do it really, really well.
Carson, just to add that one thing, when you're talking about customer happiness, like you were saying, their patience level, that's why it was designed the way it was. Like, time has to pass before they'll stomach another error.
Yeah, and that's, you know, if it's been 28 days since your big, it's like people are a little more accepting again, and
Or maybe it's 3 months, depending on your.
whatever your window is, yeah, different services. So before we get into Prometheus, crash count course on this, if we were to look at a standard Prometheus data series set, right, you'd see a line for every unique combination of labels per metric, right? So I've got a timer count, which is just how many requests have been processed by a given service and the result code and the method that was used. So if I need to get the total for a service, I have to sum all of those series together by app. So just understand, because we're going to do some stuff that's doing a lot of summing. Also, we're going to use this timer bucket, and these metrics are not going to be uniform. They're dependent on your service. I'm just going to use pretty generic names. For us at Weave, and I think the default for a lot of metric systems, because you want to detect latency for specific methods or like endpoints, right? Usually there's more than this. Usually there's like path and user headers and all sorts of stuff. But we have all the same cardinality for this, but we've just added this LE bucket. And this is going to be important later. I'm going to come back to this, but it's for us at Weave, we looked at this and said, well, hey, we have all the same label cardinality for these histograms, so we can use that information. Just to understand histograms, what that LE means, that LE stands for less than or equal to. And say we have a 1 second request come in, it's going to actually increment all the metric series that match all the buckets you've set up in your counter. So if we've set up 5 buckets, we have a 1 second request. 1 second is definitely less than or equal to infinity, and 5 and 1. So all of those get incremented up. This is going to be important to understand later. Say we have a 5 second come in, we always increment the plus infinity because 5 is less than or equal to that, and the 5, but none of the others because 5 isn't less than or equal to those. We have a really fast one come in, we increment all of them because 0.1 is less than or equal to all of the buckets we've set up. These are configurable. You want to choose a reasonable amount of those because the more of these you have, the more your Prometheus starts to just explode with cardinality, but you pick the right amount of buckets, and usually it's a setting in your metric gathering system. So that's important, because if you remember this counter, if we were to take this exact counter, the same number of total requests per service, and explode this for a latency bucket chart, this is a theoretical representation of the same number of requests, but with all of these less than or equal to's. So if you can't just go with a timer bucket and sum them up by app, because you'll get way more requests than the app actually processed, because the whole thing is cumulative. But you can always sum up where the LE is infinity.
Yeah.
So that's going to be really, really important later. So the question is, well, let's say this first. There's some duplication here. If you didn't catch that in your metrics, there's the timer count where you can sum up and get one number for a service. You can sum up the bucket with the infinity label and get the same. Or sometimes you get this like special counter for some of the histogram metric gatherers that's not got all the labels and just like a generic counter of total. We had to pick one, or one set. We decided it was really efficient, and at Weave, we picked the middle one. We picked just our buckets. We looked at it and said, well, these timer histogram buckets have all the same other labels. Why do we need this? That's not got any extra data. We always have to have this middle one because we always need latency data, and this is useless. And so we were able to cut the amount of metrics we even dealt with, and you'll see why this matters later. But we just said, hey, let's standardize on these two metrics. That's all we ever need. We always have to get it, and it has everything we need for everything else. And that's important because you'll see a lot of the queries I show you always use this metric. So histograms are cumulative. That's really important to understand. All of the requests always go in plus infinity, so you'll see that a lot going forward. And at Weave, and I don't know if it's true for everywhere, but if you need to track the latency of posts versus gets, you've probably got at least most of your cardinality in your histograms already. You probably don't need the counts. In case you don't believe me, this is a chart, a live chart of Weave, of where I'm getting the timer bucket sum for infinity, and then I'm also, for that exact same service, doing the count. And there's two metric series here, but they're the same line. So we looked at this, and again, when you're looking at like services that charge you for each metric series that you export or save, or you just look at how much processing or storage you need for metrics over a 2-year period, this starts to matter. Like, don't scrape data that you already have. So let's talk about the easy way.
If I can ask a question about your histograms.
Yeah.
Do you have the same histograms everywhere, or can a service opt into like, right, I know I'm typically around 1 second or 5 seconds or?
We have the same buckets everywhere. We've standardized the buckets. So if you remember that UI, the dropdowns exactly match the buckets that we know are supported in our system. So by standardizing the metric names and the buckets, like the more you can standardize, the better. Like
For the SLOs though, right?
Yeah,
I mean,
for
there
SLOs.
are people I think there are teams that have like long running requests that have their own histograms, but it doesn't work with the SLO system as it currently stands.
Yeah, like we've got a couple of external APIs where it's tens of seconds to get a request.
Yeah.
And our histograms are
So
useless.
that was on the roadmap. They were gonna add more classes and support. Like the very first step was like, just start with the basic request reply APIs.
Get the easy ones, get the common ones, yeah, and then the edge ones were coming, so, yeah. So here's how we do actual Prometheus recording rules to start doing this in practice. Now we have a foundation on Prometheus itself. This is not quite, but 99% of a all-in-one, calculate all the SLOs for every app in your system all at once. And I'm gonna break this down and I'm gonna show you why this sucks and how to make it better. But it does work. At the top, we've got our total, right? So this is just like that equation I showed you earlier. Here's the total requests that have happened for every app by app, times by the 0.1. Remember, that's the 90% converted into that number. In this middle section, we've calculated the number that have actually occurred. And this is where it gets weird in Prometheus. You can't just select from Prometheus all of the requests that have failed, because if for any given window, there are no failed requests, it's nil. And Prometheus will just leave gaps in your metrics. It doesn't infer 0, it just goes, I don't have data to even do the calculation, it's not available. So instead, what you're gonna see all the time in the rest of the talk is, we're gonna get in order to get the bad things, we're gonna get the total and subtract the good. And that way, all that's left is what's bad. But you always have total. Like if you don't have total, there's nothing to calculate in SLO in the first place. So this is reliable, so you'll see this over and over again. Get the total, subtract the good. And then we divide that by what we budgeted for. So this works, except for you'll notice there's no 28-day window here. I wanted to keep it simple to start. This isn't super useful because it's like the latest point in time calculation. Instead, what we want to do is add this increase, which is how Prometheus tracks. As you have things come up and go, it tracks series coming and going and accounts for that. So we're going to sum up by app the increase over a 28-day period. And this works. You could plug this into a Prometheus service. Like you can plug this right into Prometheus UI and take down your Prometheus if you're Weave. If you got hundreds of services with 28 days worth of, remember those latency buckets, that was a whole page, and that was just like 2 services with like 3 calls. You can have, tens of thousands of individual data points, and you can really, really quickly exhaust your Prometheus trying to do every single app all at once. So I'm gonna show you how to fix this and make it scalable. But it would work. And I've done it in small scale and plug it in, and you get the data on the other end that you want. The big problem I have with this, to start with, as we start to look at how to make this better, is look at this. These 3 highlights are the same metric. And I don't know if Prometheus internally, honestly, I've been trying to find out, if it internally deduplicates this or not. But either way, it's clearly just copy-paste of the same thing with slightly different usage in a couple different places. So it's doing all our apps at once, and we're really duplicating. And not only that, this is hard to read. Anybody that looks at this is confused unless you explain it to them. So we're gonna fix this with Prometheus, and you need to understand some important things about Prometheus first. Prometheus has rules. We've all probably used alert rules, where you go and you say, here's the alert called this, and here's the query, and if this returns any results, create an alert. But the other thing you can do that's really critical and super important is record rules, where you can run a query and save the resulting series as new metrics that you can use later. These rules come in groups, which is really critical. Groups are evaluated in Prometheus separate from scraping. So scraping happens on, like it goes out and gathers all your data in one schedule. And then on a regular schedule, it just runs through the rules and finds all the groups of rules, executes each group in a random order every time. But within a group, it's always one rule after the other in the order in which you specify, and rules can depend on the result of previous rules. And so with that, we can take our old nasty thing and turn it into this. And this is amazing, and I love it. This is the same calculation as that previous query slide. But it's really easy to see what's going on, because each step is doing exactly one thing. This first rule is going to run the expression here. So for every single app, it's going to go calculate the sum over 28 days and save it for every single app by app into this SLO total metric. Then we're going to get our budgeted by taking the total times this 0.1, which came from our 90%. Then we're gonna take and figure out how many actually happened by taking the total minus the good, which is what I said you have to do, you can't just get bad. So we're able to do this duplication by just reusing, and it's fine that a later rule uses a rule that was just calculated, that's available.
So the 0.1,
This is 90%.
yeah, so this is for one SLO class.
And I'm gonna
One
come.
SLO of one class.
Yes, and so I'm gonna come into the problems of this, but it does work. So we're saying this would be a 90% SLO for all apps. But it is a one-shot rule that you could stick this into, and probably not break a Prometheus in most places. But you're right, that's the 90% for everybody. So we take the occurred, and then at the bottom, I put this same equation from before, because it's really great. This looks like that, essentially. Like, anybody can look at this and understand the two pieces, and even better, there's only two parts of this that are a Prometheus query, right? Like, each of these pieces is an easy to understand single query component. The rest is just variables. It's just a Prometheus version of variables, and anybody can understand this as opposed to that, right? And so, even if you don't want to do the cool stuff I'm going into, the even cooler stuff I'm going into later, understand rules are great, and you can store them, and we're going to use these a lot. So, there's still problems, like Clint pointed out. There's still problems with this. All the apps have to have the same SLO objective. That 0.1, or 90%, was in the rule for every app, all of them had bought into that. And even with that, efficiency of deduplication and whatnot, 28 days for hundreds of apps, maybe tens of thousands of metrics, you'll get this, and Clint is probably getting flashbacks from this exact error.
Gosh, late nights.
I think it's 50 million samples is the default. So you can hit 50 million data points and Prometheus will just throw up. And you can increase that, but that's not really solving the problem. So what we go to is auto-generated rules. And again, you can do this even without a fancy deployment system. Remember this. Remember, you fill in and you pick your numbers, or you choose a class, and classes just explode into this in the back end. And we've got all our important numbers defined per app, whether we default them based on your class name, or you set them. We've got these important numbers that you set per app. This could just be in a values file. So here's some examples of real final rules and what we ended up doing and why these are great. So we're making record rules, and we decided at the Prometheus end, it doesn't actually matter if you have 100 different metric names or one metric name with 100 series, it's still 100 series at the back end. So we just went with really long metric names, and there's reasons this is kind of handy. But we generate SLO metrics, we put your service name in there, we give you all the specific information. But if you look, this is just a longer, more specific version of calculating the total. Again, we're doing that by taking the timer bucket for a service, always for the plus infinity, because that always includes all requests. So we sum up all of those to get the total. We found out how many are allowed to fail by doing the total that we just calculated times, now we can put this per app. We can take the 99% that this app wanted and turn that into 0.01. So each app gets to define that piece separately. Then we're going to get how many have actually occurred. Again, it's the total minus the good to get the bad. And at the end of the day, we get, again, this is just a longer per service, longer names, and more specific queries version of what you already saw. So this is the final result here. It's longer because we're doing a lot of per app naming. You could do other things, but this is the easiest to kind of grok for all of our developers. But it's still just a bunch of pieces, and at the end of the day, it's these really long variable names, and there's still only 2 Prometheus queries in here, right? I've just made longer per app names. And if you look at this, there's the service name here, there's the app label, and there's the 0.01. And that's all you would have to template to do this anywhere. Like, you could copy paste this and just put placeholders in those 3 places. So let's do I'm gonna step back again. This was for availability. This is all so far just been error rate. You notice every time, I haven't touched on it, but every time we calculate the good for HTTP, we're calculating all the requests that are not a 500 error, right? So this is just for error rates, and the LE's always been plus infinity because we're just using this one series as a way to not scrape extra data. You could use timer count and not do the LE if you wanted to use that. There's no reason you can't. Let's talk about latency rules where we start to do more with that though. Here's an example of the final generated rules. I won't step through them, but the final generated rules for latency, it's almost 100% identical. There's 2 critical changes. The first is that we have these names, and we have 2 latency objectives, and I decided to call them tier 1 and tier 2 because you gotta call them something. like I said, you have like I like to think of it as a stretch goal and a like absolutely must hit. But there's no prescription of how teams use those, right? But we generate new unique names. We can use a different latency number here if we want to. And critically, for the good, we take the code part out. We don't care about the return code when we're calculating latency. We just care about all of the good requests, if for a 1 second or less budget, have to be in the 1 second or less bucket. That's all it is. There are fancy things you can do with the quantile function and Prometheus histograms. I would not recommend getting into it. I would recommend just making your budget match the buckets that you already support. It makes the math a lot easier, it makes the queries easier. So that's what we did. We have 10 buckets, we say, here, you pick from one of those 10. So you just put that in. 1 second or less means you put the LE1, as long as your metrics are actually scraping and accounting for that bucket. But that's a real latency rule. And what's cool about this is, one second. What's cool about this is the dashboards are incredibly simple and incredibly efficient. You could chart 100 services SLO over 2 years, and all you're doing is charting 2 lines over 2 years. You're not doing any calculation anymore. You can have 100 developers looking at 2 years of SLOs for 100 apps, and it'll scale to infinity because what are you charting? You're charting the final calculated rule that's already been calculated, and it's just a number now. You can store that for as long as you want, and it's one number. This made our dashboards really clean and easy, and it solved a whole bunch of other problems, and this is literally the query in some of these charts.
What purpose is that?
I can't tell you. I'll tell you offline. I'll show you an even worse one later, but it's ours, so I don't feel too bad. So that's pretty cool. Question?
I was just gonna ask on the, right, availability is about like errors.
Correct.
Versus, your latency, you're including all requests, success and failure,
That's what we chose to do.
and why?
Good question. Because that's what we chose to do.
Okay.
You're right, maybe there's an argument for excluding in the good, right, for excluding like errors could be outsized long. I don't know, taking 5 seconds to return an error is kind of still a latency problem.
It would still flag under both.
Yeah, you're right, it would still flag under both, so you could decide whether or not you wanted to count errors or whatever. Like, you can kind of do whatever to decide what the violations are, right, against your budget. This is a very direct, like, no special cases, automated for everybody solution, but yeah, you could get fancier.
Well, because I'm wondering, often it's gonna be the opposite, right? Your database is down or whatever, and so you got a bunch of super fast error responses that are hiding your actual latency on.
Yeah, no, that's true. Yeah, so you could choose to break that up. I'm keeping it simple and by doing one and the other and not, but yeah. You can see how you could really easily just put that into one.
Okay, I was just curious what the reasoning was.
Yeah, the reasoning was keep it simple, keep them separate for now. Start basic. We haven't had a real need to get fancier yet, so. Moving on, that's this. That's the generated dashboard is how you get this number and this line. What I want to talk about next is how you use this data to tell your developers something's wrong. And that's alerting. Here's a naive alert that you might think you want to do, where you go, okay, well, I've got this really cool rule now that tells me what the budget is. I want you to, if it's under 5% left, or sorry, 50% left, alert me. Like, pretty simple, it would work. And here's what it looks like when it triggers. This top chart specifically. Everything's good, here's an alert, it never resolves. And that's, you may be like, okay, well, it's fine that it never resolves. The biggest problem with that, if there's another dip here, or here, or here, you don't get a second alert. If you don't resolve the alerts you have, you cannot get a second alert for another event. So that's a problem. And then this other one is illustrating a different problem. We're masking a slow descent to where this is a really, really slow downward slope line that's gonna put you under 0 at the end of your period. And so it'll either not alert at all or it might be hidden by that kind of naive 50% alert. So what you want to do is detect obviously the fast drops and alert for somebody to look at them. And you want to detect these slow gradual things. And you want to clear both of those in a reasonable amount of time so that you can re-trigger if you need to. And great alerts that do this, and this is straight out of the SRE book, use burn rate. And I'm going to show you how to calculate this, but at its core, it's just a kind of an index. And so a burn rate of 1 means that if you're burning your budget at a rate of 1, then at the end of the period, you'll be at 0. You'll be exactly at 0 budget. And 0 budget's okay. In fact, if you get hardcore in SRE and SLOs, 100% budget is bad, right? 100% budget is something your users will start to depend on, right? Any exhibited behavior will be dependent on behavior. So
And you only want the bare minimum you have to do to make your customers happy so you can focus on other things.
exactly, yeah, and it
1%.
means you're not taking enough risks, right? This is the classic OKR. If you're hitting every OKR, you are not setting like intense enough OKR. So burn rate of 1 means you're gonna go exactly 0. Burn rate of 2 means you're gonna burn out twice as fast as that. And 10 means 10 times. That's all it is. So you can take that number and see it's X times as fast as getting to exactly 0. And this is important because we're going to use this to make great alerts. We calculate this in a broad way by just taking the rate of change of errors coming in, and errors could be, again, for error availability, it's actual 500s or whatever the gRPC equivalent of that is. Well, it's like 10 things, right? We actually take a bunch of gRPC codes into consideration. But it's the error rate of change of that divided by the error rate of change of actual requests coming in. And you get the burn rate at the other end. In Prometheus land, we always have to do this, get the total minus the good to get the bad, right? Otherwise, this is really matters with like a 5-minute window. It's very easy in a 5-minute window to not have any failed requests. So that's when you hit this the most. 28 days, it's kind of good practice, but you almost never hit a 28 days without a single error. So you take good minus the bad, divide it by the good, and you get the burn rate. In Prometheus terms, this is what that is. We take the sum of rate, that's really the only change from the previous calculation, the sum of rate, and there's also you'll notice there's no 0.01, there's no 0.1. Your actual objective doesn't matter when you're calculating burn rate. It'll come in later, but for burn rate, the objective is, it doesn't matter. So we take the rate of change of the total, we minus the good to get the error, and we divide that by the total. And we get, in this case, a 5-minute burn rate calculation. And all we do, this looks like a lot, but the highlighted part is the only thing different between all these rules, right? We've got 5 minutes, 30 minutes, 1 hour, 6 hours, 3 days. Those are ripped right out of the SRE book. Everything else is copy-paste exactly. It's just that end bit that changes between these rules. And we're going to use all these to make great alerts later. But there's a lot of, just duplication here. It's easy to generate. One question you get is, why aren't you using your cool multiple rules thing here? And I did get this when I was pitching it to John. And essentially, over 5 minutes for one service at a time, or even up to 3 days, like the best I could do is split each of these into 2 separate rules, and the complexity and the middle layers weren't worth it, right? It wasn't really that much more readable. We didn't have that much data. It actually ended up being better, so we chose not to break that further. We still use them, but we don't have any middle steps because this is efficient enough and easy enough.
And you're the only team that actually reads them. All the other people don't care.
Yeah, nobody else cares. The cool part is nobody else cares. But, so here's how we do that same thing for availability for 5 minutes. It's almost identical. We take the code part out and we add RLE for, in this case, a 5-second, right? We're saying all of them have to complete in less than or equal to 5 seconds. But it's otherwise just rate in the same exact calculation. And again, you just copy paste that and change the end, all the different windows. Those windows are important because they'll come in later to your alerts. So once we've got all these rules being calculated, we can start using all these different burn rates to actually do great alerts. And this is an example. It's a lot to read. I'm not going to try to explain it here. You kind of have to look at it for a while and look at the charts to get it. But there's 2 events that are going to trigger a page level, right? So you can actually like PagerDuty or whatever, send somebody an alert like you need to look at the error rate, it's burning too fast. One of them is within both a 1 hour and 5 minute window, you're burning 13 times faster than you should to get to 0 at the end of your period, right? So you're basically burning 13 times faster than the absolute most you could. This is where your 0.01 comes in. So the error rates don't care about your objective, but you multiply this calculation of like your burn rate number, like your ideal burn rate number, with your budget. And the reason the 30-day window matters, all this is honestly copy pasted out of the SRE book. Like, other than the long rule names, and I had to tweak this number for a 28-day window, you can rip these straight out of the SRE book, and I encourage you to do that because they're smart. So either this is true, or within a longer window, we're burning a little bit less, 5.6 times faster than we should. If either of those are true, trigger an alert. I won't go into the details of how this works, but what it means is you get this. You get an event, you get a page, And depending on a bunch of relationships between how you build that rule, and there's whole pages on like what rates and what burn amounts and the windows and how those, like a window of this means you resolve within this time but you don't trigger until, like any good thing, it's give and take. You decide you want quick resolution or fewer false positives, but essentially you get, here's an alert and it can resolve quickly, which means that later down the line, I could get a new alert later and for another series of burns, which is really, really the important part. Like I can get alerted a second time if it burns again. So here's a real life example of everything's pretty good. Here's a crash of error rate. We've lost a bunch of budget, right? We've gone way down to the negatives. Here is those rules that I showed you overlaid in a chart, and I put it underneath the the error budget. So we're going along fine. We've still got kind of some latent 3-day rate that's here, but you can see there's a big spike and then it kind of evens out. And that happens because the longer your window of the error burn, the longer it's going to last on these charts. And here is where I overlaid it with the actual when alerts were triggered. So these 2 red bars is a trigger and resolve of a page level alert for this service of burn rate. The long yellow section that you can kind of see is a ticket, right? So it's a ticket, like kind of a lower tier alert that, hey, something's still kind of weird. They don't always trigger both. In this case, it did. So you see that we actually create 2 different alerts. I didn't show you both, I only showed you the red one, but we create 2 different ones for different kinds of alerts. And again, the critical part about all of this, you don't have to really understand it, understand that it's gonna trigger and then it's gonna resolve and I'll still have had that ticket, and I still see that stuff has happened, but later if I do another burn, it can come back later. And if you look, I'm pretty proud of this because it basically is a real life example of these. And it's just with the rules I showed. Like I've showed you literally everything that went into this chart. By the way, this is what I want to replace that right-hand part of that dashboard with. I don't like one burn rate, but I love these windows and showing you when alerts have triggered over time. So we'll probably be using that data. So this is that full, all of those 3 things stacked on top of each other just for reference.
I can ask
Yeah.
So that mirrors, at least for us, what most of our scenarios are, right? It's a big, massive break versus a slow degradation over time. Is that indicative? Is that representative of Weave, or do you have a lot of?
I think we have definitely more of the big breaks than the slow gradual. Like we create the other one to try to like, you can structure your alert query to be more on the vein of detecting long bleeds, right? You say like, if over the 3-day window, we're burning at a rate that means we're gonna get under like, and you can detect like a 3-day kind of pattern. But we mostly have the quick ones as well.
And I don't have the actual data to prove it, but I think in the early days of Weave, it would have been super helpful to have the long burn because I think we would have caught some things that we didn't catch. And then they got to the point where they just like tanked, right? It's like even on the phone side, like we were hitting Django, the latency got to the point where if it got bad enough, all of a sudden the phone system stopped working if the latency was too high on the API request. We didn't know that until we got the dashboard set up. You could see the latency keep going up and up and up over as the day went by, and then all of a sudden it just flatlined and nothing worked anymore. And I think if we would have had like burn charts that say, hey, we're gonna miss our error budget at this rate, we keep adding customers, we could have preempted that a little bit better.
So the idea being you don't have the break.
Yeah.
So it doesn't ever alert, but it's because you caught it early.
It creates a warning is what it does. And so it doesn't page you, but
Right.
when you come back in the next day, you can see it. Like, okay, should we look at this? Is this something that's gonna affect it? Yeah.
And that's all just various combinations of
So
those.
we've already reached peak SRE. We only have bad breaks. That's my takeaway.
So anyway, so my advice on that is use the 30-day window, steal their rate burn windows and steal their alerts. Like they make them look like Prometheus queries in the book. It's public. You don't have to buy the book. It's on the internet, right? Like use it. They're smart. They work pretty well. Start there at least. Like start there and customize because even with our 28-day window, I only really had to tweak a couple numbers, and I can talk about what I had to tweak offline. But if you pick all this, you can just rip it straight out and get great alerts. So that's a lot of Prometheus. That's a lot of numbers. I want to get on the cool, fun stuff to close it out with, like Kubernetes and cloud native and cost. So what about the dashboards? How did you get these beautiful generated dashboards? And we did it with the Grafana operator, sort of. So the Grafana operator exists. It will make your Grafanas, and it can make data points, and it can make plugins, and it can manage multiple Grafana instances, and it can make dashboards. So if you're running a Grafana in your cluster with the operator, you can put some JSON blobs of what, Grafana dashboards are all just JSON. You can put that in a CRD and have it make a dashboard for you. Doesn't work for Grafana Cloud. I'm going to talk about that later. But even though they're the same API, the operator just doesn't know how to send the request to Grafana Cloud. So we use the operator SDK to build a custom operator at We. And I know that sounds like a lot. Offline, when we have more time, I can show you the code. It's like 300 lines. It's actually a relatively simple operator because it's just reading some YAML and splatting it at an API. What it does is we take a sample dashboard JSON. I'm going to show you how we build that. We have some string substitutions of that JSON that we just tell the operator just do some find and replaces and send it to Grafana Cloud. There's an apply endpoint. You don't even need, you just upsert that big JSON blob. And what you get is something like this. This is that one I told you was really bad. We actually have a reference service that constantly violates SLOs all the time. And its equilibrium is about negative 1800%. So it doesn't go any lower than that. It's no hit where like it errors at a certain rate and that's its like 28-day equilibrium. But you'll notice there's a lot of places
on purpose, a reference service?
Yes. It's on purpose. Because we want to make sure these numbers are working and make sense. And these are real metrics. This is a dashboard that we have it could be in Grafana Cloud or whatever, but we said, put placeholders where you want things, use metrics as placeholders, real metrics. So if you want to change what the dashboard looks like, you go edit this, save it, and go export the JSON and just plop it in. And those string substitutions will allow us to, like we had this talk a little while ago, like how do you maintain a generated dashboard? Like how do you maintain the big ugly JSON? And my answer was don't. Like just make a real one and then replace all the things you need to when you're doing generation. And that makes it sustainable. Here's an example of that CRD sanitized for recording, but essentially we say create a dashboard, go against this Grafana. We made ours work with local Grafana and Grafana Cloud, so you can develop this without even Grafana Cloud. Give it a title. Here's where you splat that big JSON that you ripped out, and then here's an example of the replacement. In reality, we're replacing not just these app names, but our sample metrics with the generated metric names, because we know what the metric names are going to look like on the other end. So take out from the dashboard the sample ones, put in the real one. It's just a bunch of string replacements on a big JSON string. And at the other end, you get this. And this is really important to us because we wanted to generate dashboards with this sentence. Like all of this was so that I could put this sentence in this spot on these dashboards. Because the alternative is either you have some other non-Prometheus data store where you store the objectives for every app, or you have a label that's really long somewhere that you save to Prometheus every 30 seconds for 2 years just to keep this one string in there. So we decided to do all generated. Then we had a scale issue. So we got our dashboard solved. Here's a really fun one. Our main Prometheus is big. We've got a Prometheus per every cluster, even if it's sharded or whatever, which I think it is now. It's really big and it's really busy. And more importantly, because it's so big and busy, it's got 14 days of data, and after that it goes off. But you can't calculate a 28-day window SLO on 14 days of data. You just can't, because it's not there. So you have choices. You could up the main Prometheus to 28 days and keep all of your metrics for all of the clusters for twice as long as you really need to. Or you can solve this a better way. And even with our best efforts, hundreds of apps, those calculations, they're discrete operations for one app at a time, but that's load that we don't want to put on our main Prometheus. It's already busy. So we solve this with Prometheus. We have a Prometheus operator and we can make an SLO instance. Really easy, I'll show you that in a second. So every single Prometheus out there in the world has a federate endpoint. If you hit that, you say, I want you to give me all the data you currently have at the latest set of data you have matching this query. In this case, we're just getting one metric by exact name. We scrape this one. This top one still talks to all the things. It's always scraping. It's the main knowledge center. It's still only got 14 days of data. This bottom one just says, hey, periodically, I want you to tell me all the metric, the SLO, not the calculated. Don't do any calculations. Just give me the raw data, and I'm going to store that for as long as I need to calculate my SLOs. So that allows this one to still, we don't have to integrate the second Prometheus with all our apps. We don't have to have it do a lot of scraping. It just says, hey, just give me the data, I'll keep it and do stuff with it. And that's all. This is a shortened version of all it really takes, right? Once you've got the Prometheus operator, a second Prometheus, especially one that's only doing one targeted task, costs you almost nothing in compute and almost nothing in maintenance because it's just a new CRD with a higher retention, right? So we're saying, I want you to only scrape things that we're going to give you. This is going to come back later, this scraper Prometheus SLO configuration. We throw this in a Kubernetes cluster that's got the operator in there. You get another Prometheus with almost no effort. And then we can make a pod monitor. We're going to say, hey, SLO Prometheus, I want you to target the main Prometheus, and I want you to scrape these two metrics. You could do, in fact, this shouldn't even be a tilde because it's an exact equals. There's no, there's a couple other cases where we actually do regular expression matching. But you could just do a series of matches and say every 30 seconds from the main one, I want you to scrape the SLO data and store it. And I know that it's going to keep it for 28 days. So we solved our window. Now we have a second Prometheus that can do all the number crunching, store all the data for as long as it needs to do its crunching, but we have a retention problem because management wants 2 years of SLO data. Yeah, he's just nodding, yeah. They want 2 years of those SLO numbers.
We only said 1, right?
No, it was 2.
2?
Yeah.
Management.
Anyway,
I don't remember saying 2.
whatever it is,
I'm embarrassed a little
you
bit.
probably want more than, the truth is you probably want more than 28 days for sure. Whatever it is, it's not 28 days.
To make the long-term product decisions, sometimes you have to be able to see like, okay, we didn't have an outage like the whole year.
Yeah,
We can go nuts.
Yeah.
Like, let's, yeah.
No, it's not, I'm just being sarcastic, but even if you don't want 2 years, 28 days, you want more than 28 days for a 28-day SLO. You want at least 2 or 3 times your thing. So whatever it is, we say 2 years because that was a real life thing. And if we turn this up to 2 years, yes, it's only got a subset of metrics, but these are still a lot of series. These can be tens of thousands still. We've offloaded a lot of it, but it's still way too much to turn this to 2 years of retention. So how do we solve our retention issue with Prometheus? With Prometheus. And so we said, well, we can make another Prometheus, and we can scrape one layer down. And so that's what we did. We have our main one that's per cluster that has, again, this is the only thing that ever has to integrate with all our apps. Everything's already using it. We scrape all of the SLO metrics here and do the number crunching here in the middle. And then at the end, we have this export instance that lives for 2 years, and it just scrapes, you'll notice, just SLO. I don't care how you got there, I don't care anything else, I just need the series that I will need to use for alerting over time. And with that, at the end of the day, you get almost no data in this 2-year term. And we do that.
One of all of those per cluster?
Yeah.
So there's not like a centralized export that's grabbing on, okay.
I'll talk to you, yeah. So this stack exists in every single cluster because it doesn't cost almost anything to run these bottom two. The truth is, one pod does it just fine, and you don't even need high availability because if it's down for a couple minutes, it's not the end of the time in the world. So this costs us almost nothing in compute, CPU, storage, whatever you want. Management, right? Because that other bottom layer is another CRD. It's basically the same thing. We call it 2 years, call it Prometheus export. I'll tell you why I call it export in a second. We kind of talked about that. But we're just saying 2-year retention, I want you to only handle configuration that's for you, right? This is how you in Prometheus Operators separate these rules for specific instances. So we're saying, hey, I want the export instance only to target the SLO instance and scrape the calculated rules every period. Right, so we're funneling it all the way down, and it's 2 CRDs from having that third layer. So this is what the funnel looks like of metrics. We've got the big boy at the top, integrated with everything, taking all the metrics, then we're gonna filter it down, have a lot fewer, but still a lot, and all the number crunching is done in the middle. And then at the very end, we get this export instance that's just got, per app, I think, per app, per SLO, it's like 6 series, which is not anything in metric scale. And it's just this fine, like, pinpoint, 2 years will keep the SLO history. And I call it export because this is fantastic and you don't need, like, this is good enough for one cluster or small installations, but we have lots of clusters distributed around the world and we want to look at all the SLOs across all the clusters. So we take this export instance and we use remote write to send everything to Grafana Cloud. And this actually solves 2 problems. Remote write has no filtering. If you've never used it, it's a little setting in the Prometheus config that says every time you scrape data, also send it there. And that's it. There's no, every time you scrape data with these labels, blah, 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 it's like, no, if you scrape it, put it here. It's how Grafana Cloud integrates with your Prometheus. It's actually how Thanos and a bunch of other things integrate with your Prometheus. And if I got really fancy, I'd tell you that in the middle, we actually have Thanos with an exporter writing all of our data to an S3 bucket, or the Google equivalent of an S3 bucket. So If we needed to go back and re-crunch all the numbers, we could go load them out later. We use the same remote write capability. But right here, it's, once we've got the final SLO numbers, we remote write them to Grafana Cloud, which has, it turns out, a 2-year retention that we just get in Grafana Cloud. So, what about billing? I'm going to show you our history and how this stack solved that problem. Here's what happened when we turned on, in our main Prometheus for one cluster, like a year and a half ago, ship everything to Grafana Cloud. It instantly went to, it's kind of gray, at least in person, to $500 a month. And that's for about 30,000 series for one cluster. We had multiple clusters. And now, our biggest clusters are like 90,000 series, right? So you could easily have, and they would, sure, Grafana Cloud would love it if you had a multiple tens of thousands of dollar bill by shipping them everything. We really just wanted SLOs. Like, we have a Prometheus, we have Grafanas, we don't need it for anything other than aggregating every cluster's data. So this wasn't going to work for cost and a bunch of other reasons. So we decided, let's just ship that middle layer. That SLO layer doesn't have everything. It has a lot, but not everything. And it got better. You can see the cost is cheaper, but as we added SLOs, especially here, we started, every time a service deployed with SLOs enables, there's a monetary cost, a non-insignificant monetary cost of SLOs, because we suddenly started scraping a whole new series of latency buckets, right? You could pull in 10,000 new series from one app that's got a lot of variance of metrics. So that wasn't sustainable either. That's a increase, like a huge cost per app, potentially.
Per month or per day?
Per month. Now, again, you could argue that's enough, but as I looked at this and decided hundreds of apps, like what, 300, 400 apps at Weave per cluster, that is that number, that wasn't gonna scale. So we took that bottom, and we had that bottom layer, which remember, in Prometheus land cost us nothing, 2 CRDs to have that bottom layer. Here's where we stopped sending the data, and here's where Grafana stopped counting it as active and billable, and now this is the chart forever. Like, if you were to go on this, so like right now, that's the number, 0. It's $0 no matter how many people do SLOs, no matter how many clusters, because it's every service, it's like 6 numbers, right? And Grafana Cloud gives you like 10 or 20, they keep upping, it's like 25,000 for free now. So like, I don't think we'll ever pay them anything. This is,
Google like offers their own metrics thing, you're like, oh, poor Grafana Cloud. You just throw them a bone.
Loki's, I hear Loki's the big one anyway, so logging is a different, we actually also don't pay much for logging, but that's a different story.
Default off.
Default off.
Baby.
Just don't.
Just don't.
This is the forever, because again, it's just these final calculated rules, and even if you're not on a cloud, that's so much little data for 2 years. So this is a full timeline of like where it started, and at the end, it basically looks like where it started at, even though we're still using it every day. Like that far number is basically 0. So final words on SLOs, standardize your metrics. This whole thing at Weave would have been 20 times harder if all the different services could use different metric names and different behaviors, right? The fact that I could say, everybody's got these 2 metrics, and this one behaves like this all the time, so I really need this calculation for everybody. Like, it meant that with all of that in there, most of the end Prometheus rules I showed you have like 6 unique things per app. Like, it's otherwise generated. Standardize, pick a couple, maybe just, honestly, latency is hard for people to understand. Like, if I was gonna pitch this now, I would, just like if I was adopting OKR somewhere, I'd say, pick one that everybody can understand, get buy-in, and then add more complex ones later. Do the 30-day window, mostly just, if nothing else, I can show you how, but mostly to make those burn rate, like queries easy and just copy pastable, and automate and generate.
Unless your weekends drop a lot, then do 28 days.
Yeah, yeah, that's fair. So that's it. That's my whole spiel on how you get there and the detailed work, and it's illuminating.
Do you have any like queue workers that you're reporting SLOs on?
Not yet. We are still trying to get anyone to agree on what the objective measurement is. Everyone can agree for a request, it's the result of the request. But you're right, we do have, there were plans like, that's why if you remember the config is called request class. SLO request class, and the custom is like request spec. Because the idea was we're gonna come back later and have different predefined classes for queue type SLOs and add in some more like common ones. People have talked about it, but every time I ask them, like, well, what do you count as good? Like, at the end of the day, you have to say, like, how are you gonna which ones are you gonna consider success and which ones are you gonna consider failure and total? If you can tell me how to calculate the total, the good ones and the bad ones, I can help you build SLOs. And so far it's been hard to get people to agree on, because everyone handles, there's too many queue systems at Weave, first of all. So there's no standardized metrics, and that's been a big blocker. And everyone handles them a different way. So, but you could, I mean, you could say like, how long it takes to process a message. If you can track that, you can use that to say all of messages should get processed within, 99% should be processed within X seconds. Like you could do, that's the easy one, I think, is a latency one. We're not doing it.
Well, that has like, then you have like now kind of two separate latencies, right? There's the latency to actually do it, and then the latency from when it was actually inserted. If you're right, it's on a back off, retry, something or other.
Yeah, and you almost need two budgets, right? You need like the time to receive. For our deployer, we have like 4 of those numbers. We have like how long it took for the for it to like get your request and start its process, how long it took for Git to do its thing, how long it took for Argo to do its thing, like, and you'd have to track, right? Because you're like, my service didn't even get the message, but to the user it doesn't matter. To the user doesn't care, like,
Right.
my thing didn't pop up for 5 minutes, it doesn't matter where that happened. So you're right, you probably do a couple different numbers.
So when you're setting up the alerts, you had that burn rate of like 13 times and the other burn rate was like 5.6. Where did those numbers come from?
Those come from the SRE book,
Uh-huh.
slightly tweaked for a 28-day window.
So just trust Google, basically.
Good default.
Yeah, those are good defaults. They tell you exactly how those numbers, how high those numbers are and what you choose and the windows you choose impact how long it takes to trigger, how long it takes to resolve, like time, like that's a balancing act. So they basically, I'm sure, I've seen some fancier ones where you literally have a form for alerts, right? Where they're like, for your SLO alerts, like tell us, slide on this scale, which part you want to prioritize, early trigger, like, or like early recovery, and it can spit out. So maybe if you got really fancy, we generate those based on like the equations and how those, but I didn't cover here because it's super fancy. But if you go to the SRE book, the alerting part, it shows like how those numbers got picked and what they do when you make them go bigger or smaller.
And it's scaled down from 15 and 6, I'm guessing? If it's 30 to 28?
Yeah, exactly. It was, I think the numbers got just a little bit smaller to, mostly it's actually a function of the windows. Because the windows of the book are like, 3 days. 3 days and a 30-day window come out to a pretty even number in a lot of places, where 28 days and a 30-day window, or sorry, 3 days and 28-day window, that ended up not being round.
Yeah.
So if you chose different alert rates, like it is, I forget, I actually looked this up because I put those magic numbers in our code at one point and then never changed them, and I, before this talk, was like, how did I get those again? And the SRE book doesn't tell you, maddeningly. It was some other blog post from some company where they're like, and here's how those burn rate numbers, like, you do, like, 3 days is so many hours, and you divide that by the number of hours that your 28-day window is, and I don't remember what it was, but there's an equation that gets you those numbers depending on your alert window. Yeah.
Do you have anything that you'd call like real user metrics? So seems like a lot of this is probably monitoring more like back end or maybe load balancer to back end side of things, but like actual end user latency, or if you have business objectives, like I know Netflix loves their streaming session start metric. That's their SLI on just about everything for like monitoring how healthy end-to-end processes. Have you
This is
any of those, or?
like that gets into almost like black box. I know what you mean though. You're like, if I'm on my machine, and I call into your service, I don't care that your service is hitting its latency, like the load balancer added time and that broke it. Like,
Or the person in Australia, they always get screwed by the speed of light. So.
yeah, exactly. No, we don't have, right now it's, I mean, we have front end services that use this, but it's not all encompassing. It was the start, so.
Have you found like at an exec level that they want that like are SLIs of business indicators actually useful?
We never
or
got
is it-
sold to like the higher levels.
It's coming back. We've had a lot of talks recently about SLOs.
Good.
It was actually really popular at Walmart because their system was so complicated that, yes, you could have all these graphs and it wouldn't matter because what they cared about was orders per minute. And like, that was the metric that the entire business was driven off of for e-com. Because if OPM was down, we weren't making money, and it didn't matter what the problem was. To your point, like, oh, my database, who cares? Whatever the problem is, that's what the SLI is trying to hit, is there a problem? Is my problem within my SLO or my SLA? And OPM was what they latched on. It was crazy how accurate it was.
That's interesting to define. So you're saying like define your technical performance SLOs based on whatever the business metric is, because that's not a performance metric from a technical standpoint of orders per minute. That has to do with marketing and a million other factors that technologists can't control. So you can't put an SLO on the engineering team to say orders per minute.
It's where the separation, because SLIs don't just turn into SLOs, right? And SLO isn't the end either. If you're providing a service, SLO is usually an internal metric that you try to guide yourself on.
Yeah.
You don't publish it, you publish an SLA,
Yes.
which might even have some, monetary ramifications, but it's not the same as your SLO.
I think we're trying to use it, I don't know, a lot to bridge the gap in some of these really high throughput services where it's like addressing every possible error in Century or whatever is not possible. So it's not the end all be all, for sure.
It talks about that in the book a little bit, because I was just reading through some of the chapters today. Is like this is assuming that your product team has already defined a product that users like. This is after that, right? Like if you don't have product market fit, none of this matters, right? So this is just the technical performance that affects the user happiness.
I like it as the measure of like, I want to try to bring it more into like our product planning, be like, are we at a place where we can make risky changes? Or actually, everyone's right now really like internally saying like, we want more time for craftsmanship, we want more time for tech debt cleanup. And if you can point to some objectives that you're missing, it's pretty easy to say like, let me clean this up, look at these numbers, like.
Or saying, hey, this area is good, let's stop working there, let's go here.
Yeah,
So
exactly.
they just changed their SLO to critical for all their services. Like, look, we're not hitting any of our priorities. We want to work on tech debt.
You see those.
Comes in and it's like, oh, let's make our own internal Cloudflare that just papers over all the terrible internal systems.
Interesting thing, if you just change your
All our
SLOs,
smart people there.
no, that's actually one cause of a lot of the jumps in that history. Because history is,
changing them.
yeah, it's like, you go from like,
Is there anybody online that wants a question?
I have more questions.
okay.
I expected that.
Oh.
Fire.
Well, I also volunteered speakers for today. What about, like, right, I get how this plays out well for those high throughput services. What do you do for, right, the random, we get 12 requests a day, or we get 100 on some days and 0 the rest of the month?
You have two choices. You don't SLOs, or you do artificial traffic.
Big traffic.
Same thing with we've been talking about this with canary deploys. Like, what do I do? You can't do a canary deploy, like slowly dripping in traffic based on success rates if you don't have enough requests per evaluation period, right? So I think you have to fake it or just, it's not a tool for that job. If you only get 100 requests per minute, you can just handle every error individually as a Sentry ticket, right? Like almost like, yeah,
So,
that's
like,
the classic
In
answer.
your YAML, whatever, right, you would say, I'm opting out of SLOs because it doesn't make sense for me.
Well, so
You have to opt in, but yeah.
if it's a service that you care about, I would probably, and it was so low volume that you can't have real traffic to monitor it, I would probably be smoke testing it. Like, I would have some fake traffic that I would send to it that makes sure the system is still there and running. Because you're right, like, if it's so low, but like every time something came into a queue, you had to make sure you processed it, I'd put
like the smoke test.
So like the down website, you probably should check it out every so often.
I guess.
Like, for us, it's our BigQuery schema change, right? We have, every customer has their own set of tables in BigQuery. And we only change the schema every month or two. But when we do change it, it's, now a bunch of stuff to be done. But yeah, right, it has to get done, Sentry error tickets are fine. I'm just wondering,
You can see, this is a metric that's clearly developed with high throughput services, right? Like it's Google, like super high throughput concept. So it doesn't apply to everything. The other thing they do, they recommend is like condensing a lot of services into a larger, into one larger unit, right? right? So like, if your service enough hasn't do it, you wouldn't do an SLO, you would actually sum up across a whole series of apps and do, that, which is sort of an artificial way, I think, to get more traffic.
So in a, like your data mesh, it's your data domain, whatever, so.
Yeah.
I don't care what's happening inside your black box or how you've microserviced it or not.
You could do both too. We talked about this, like, you have an objective that's a broader scale that sums up several apps or all the requests with a certain critical label across, and because right now we're doing it per service as a way to help developers understand where to focus their time and where problematic services are and what ones aren't. But you could do all that and have a broader objective that is impacted by more services to get a better feel of like, here's what our front end experience is like across all the services. So that's their example.
How much are developers bought into this? Like, did they care before? Do they care now? How do you make them care?
That's a good
It's a good question. It's been done for a year.
And it doesn't get any easier. I'm gonna like pat myself on the back like.
Day one bit.
Yeah.
But it kind of goes back to that first conversation of how do we tie in the business, to, and it's almost like what you're saying, Greg, is this notion of how do you find that one button or that one chart that makes everyone concerned about it? And then you articulate it downward. Because coming upwards sometimes is really hard in this world, right? You almost have to start with the business.
Do you still do the team reviews, like the quarterly team reviews with just the team? Okay, well, that was where we were trying to push it, because one of the first sections was, from the engineering side, was, okay, what are your SLOs? Like, what are your report metrics? And we had like 3/4 of meetings, and they still weren't developed. And it got to the point where I was like, guys, just pick latency and error rate. Quit overthinking it, and we'll get there.
Well, start there at a minimum. Let's get some numbers out. Like,
Yeah.
it's
Leadership has to keep asking. Like, you have to have leaders in there that say, hey, how do I know if your service is healthy? Prove to me that your service is healthy. I don't believe you until you show me the data.
Or you have a system that doesn't let you deploy it without having them specify.
yeah, it's true.
I mean, that was the ultimate goal, was to say like, hey, we have a checklist of things that you have to accomplish that are done before you can go to prod. And that was one of them. You have to have your SLOs defined. If you don't, then you can't deploy anymore. Like, sorry.
We've actually started talking about Brandon's idea to start gamifying it.
Yeah.
Right? Like giving scores and leaderboards for like teams with the most
Carrot
services.
instead of a stick.
You love them. Love them. Well, I mean, because at this point, I think what we did with automation is nobody can say it's too hard to do them. Nobody in the world can say it's too hard to do SLOs. Like, that's gone.
You made it gooey.
It's never gonna get any easier. It tells you in sentences what the heck you're talking about.
Just press the default button and it's done.
But Jason sent me a quote from the SLO, what was it, the DevOps newsletter. It was so good. If you make it too easy, they won't do it. So I need to send it to you. They have to feel a sense of accomplishment after doing something.
This was,
I'm not joking.
no, what's the boxed cakes? What's the big brand of boxed cakes, like cake mixes?
Betty Crocker.
Betty Crocker.
Up their price.
OG Betty Crocker said, just add water. They had the technology in the original release. Here is just a bag of powder. Add water, you got a cake. Sold like crap. As soon as they did that little thing that you've all seen now, where it's like, and add a couple of eggs and some oil and some milk.
I'm a chef!
Gangbusters. No, seriously. Everyone felt
I
like
did this!
and it didn't taste any different. Probably
You
not.
should just make them type it in the manifest manually, then they'll feel good. Oh, yeah, okay. I feel like I did this.
So, yeah, but there's a lot of truth to that.
Some of the,
Do you guys have a dashboard of how many teams have adopted SLOs?
No, and I've talked about that. We started using a lot more demo dashboards for.
That's how we used to do things when they wouldn't get done.
Yeah, that would be great, like
Which
leaderboards.
teams had done them, which ones hadn't.
And-
Stare at it all day.
Want to be on the big TV wall,
Yeah, big
right in the
TV.
middle of the development.
Which team has not done it?
well, I would be interested, like, especially where you have, right, dashboards per person, right? If you can get some Grafana analytics for, is anyone looking at this generated dashboard?
Yeah, there you go.
Right, like, and who, right? You've
That would
got
be good from like the
into it.
DevX experience team side to measure the output, like are their customers using what they're building? I love that.
I mean, like, we have our Grafana stuff, and like my co-founder, he just has his terminal set with a little CLI script that queries stuff, and so when I ask him how something's done, he goes into his terminal and like scrolls up like, oh yeah,
Oh my
looks like this is where it changed 6 hours ago.
I mean,
And,
I was so naive, I just thought everyone would be super excited about this.
well, it's,
I was like,
and so I keep trying to, it's like,
look at all this measurement you get for free.
yeah.
thought no one used it, because we never heard about it after we built it a year ago, and
But people are using it,
people
right?
are using it more than we thought. I mean,
We actually,
20 services, 25, 30 maybe out of 400, I mean, it's not the majority,
But
but,
some of those are pretty critical.
oh yeah, our auth services, but even after you opt into it, you gotta wait a month to get
to
the
start
data,
getting good data,
right?
that's
To
the,
get good data.
we didn't implement any sort of backfilling, we didn't, we could get really fancy, right, but
Let's just take it down to the development.
let's actually close the thing out so we can,
Thank you, guys.
you stay online, we're just gonna stop the recording.
Thank you, Clint.